Okay, so we're going to be talking about stoichiometry, and this is how it goes. The basic or skeletal equation is the grams of A, which would be given to you about some product or reactant. Okay, so this is what is given. We then convert that to moles of A. Okay, so this same substance, we're converting it to moles just using the same stuff that we've been using for the past couple weeks. So you would use the mass from the periodic table. It's going to be involved here, okay? And then you're going to convert that to moles of B. So this is what you're looking for, okay? And we go from here to here using that mole ratio that we just looked at in the previous video. And so that's using the ratio from the balanced equation. It has to be balanced. That's why balancing is so important, because if you have this wrong, you're going to get the wrong answer. And then finally, we convert that back to the grams of B. So again, here you're using the periodic table to figure out what the mass is, so that you can properly divide. Okay, so once, and here's what I suggest that you do. At the top of every problem, you actually write this out. Grams of A to moles of A to moles of B to grams of B. And you just follow that in your balanced equation. You label what's A and what's B, and then it makes it so much easier. All you have to do is what they call plug and chug, chugging along like a train. You're plugging in the numbers. And it makes it pretty simple. So you always have to make sure that your equation, your chemical equation, is balanced and solved, or so that you can solve. And so this is balanced, and I just balanced it. And I want to ask if you can tell me what kind of equation this is. How would you classify this? Again, we have a fuel, oxygen, a waste gas, and water. And if you're guessing combustion, you're catching on. Good. Okay, so the numbers that we would start with would be given to you in a problem. So what I'm going to do is I'm just going to say, okay, what if we have, or you're given 156 grams of our fuel, and we want to find out how many grams, what would be the mass of water that we get. Okay, so here's how we would set this up. Again, we go grams of A to moles of A. Okay, and then convert that to moles of B, and finally to grams of B. So it plays out like this. We put our given the same place we always do, 156 grams of C3H4. Make sure you're labeling, make sure you're putting your unit. All right, and I'm going to scoot that up just a wee bit. And so now that's our given, that's our grams of A. This is what we're doing right now. So now we have to convert that to moles. So in order to convert that to moles, I'm going to have to do what with this mass to get rid of it? Divide. So C3H4, how many grams is that for every 1 mole of C3H4? Again, this goes back to week 2, I think, whenever we were getting started on dimensional analysis. Okay, so I have to multiply the mass of hydrogen by 4 and add that to 3 times the mass of carbon. Again, that takes us back to the problems we did for chapter 7 not too long ago. 3 weeks ago, maybe 2. So whenever you do that, you end up getting 40.057, and I'm using the masses from the periodic table that I shared with you 4 or 5 weeks ago, whatever. Okay, whenever we did empirical formulas and those kind of calculations. Okay, so that takes me here. So if I were to stop calculating, you would see that grams would be canceled and I would end up with moles of A, moles of what I'm given. This is what I'm talking about. All right, but I'm not done. So I'm going to continue. And as I mentioned up here, this is when I'm going to use my mole ratio. So they're saying, okay, you're going from this to this.